HTTP is the backbone of the World Wide Web. It is what allows you to watch YouTube, browse Facebook, 4chan, and much more. For those of you wanting to get into hacking web apps, knowledge of HTTP is essential. So what is HTTP? Well, I could go on about all the nitty-gritty bits, but in this series I will only cover what I personally think you will need to become a competent web hacker. So let's get to it. Before we look at HTTP, let's cover some need-to-knows. So what does HTTP stand for? It stands for Hypertext Transfer Protocol. From this we can understand a few things. It is text-based, other than when we send binary data, such as a binary file. Another thing is that it's used to transfer data, in this case mostly text. It is used to allow web-based applications to interface with each other and exchange data. Simply put, it is the messenger of the web. Another thing to note is that both devices must both speak HTTP for them to interface with each other, like speaking the same language. The HTTP protocol follows the client-server model. Often when we refer to a HTTP client, we're referring to some kind of service, software, application, etc. that is talking to a HTTP server. This, for example, could be a laptop running Firefox, and Firefox is what we're using to browse a HTTP server. It could be, say, curl, which is a command line tool used to interface with a HTTP server, or anything like that. Now we've covered what a HTTP client is, let's look at what a HTTP server is. As the name suggests, a HTTP web server is anything that's running a HTTP protocol aligned service. For example, Apache will sit on HTTP since Apache is a HTTP web server, along with say Nginx, which is also another HTTP web server, and anything like that really. The role of the web server in this case will be simply to handle and process all requests coming from the client, deliver an appropriate response to said clients, for which the clients will then process that response and render it to the end user. There will also be cases where there's say SQL and databases involved there as well. The web server will also be able to connect to those for any additional information it may need. Let's take a look at an example HTTP conversation in action between a client, a Firefox browser, and a server. In this example, a user goes to blog.com. Upon going to blog.com, a request is made. The server then processes a request for a response to be created. A response is then issued back to the client, and then the client then renders a response, therefore saying welcome. HTTP is a stateless protocol, meaning it does not keep track of user sessions. For example, when you go to your favorite website and you add something to your basket, it knows. Well, how does it know? Well, it doesn't do that by default in HTTP. It uses what's called cookies, or session identifiers, where effectively a server will give you a token or a cookie. You will then do some kind of action. The server will then update the information on that cookie, saying yes, this cookie refers to this user, and this user's information specifies this cart or this basket, and therefore these are their orders or they're logged in, that kind of thing. Let's take a look at an example of cookies used in a HTTP conversation, where the server will first issue a cookie or a token. The browser will then store that token and then use it in subsequent requests. The server will then know what's been done in that user session and will therefore be able to give the user a tailored experience, such as, for example, giving them their cart. Here we have an example of a user making a request to blog.com. When they click it, they're going to make a HTTP request to the server. The server will then process a request and then issue a response back with a cookie, if the server is configured to do that. The cookie will then be stored in the browser to be used in subsequent requests to that server. The cookie is then included in the next request, and then the server will then process it and then return a response relevant to the cookie provided, saying welcome back rather than just welcome, as it knows the user's previous session. This is similar to when a user logs into an application. A cookie will then be given to that user, which is then stored in that user's browser. That cookie then, when used to subsequent request, will then be processed by the server, and the server will say, yes, I have this cookie in my database. This cookie refers to a user account. This user account has this information. For example, the current user's name, email, etc., and maybe their shopping cart. Now we understand the basic HTTP request response cycle. Let's take a look at an actual HTTP request. See what's inside it, see what it looks like, see how it's formatted. HTTP is set up into 3 sections. We have the start line, which dictates where we're sending our data to, how we're sending the data, and the version of HTTP we're using. Headers dictate configuration information, for example our current cookie, the kind of encoding of the body we're going to send, and the length. The body can contain information like a file, parameters, or JSON. Often it's all plain text, but there can be binary in the body. Let's take a look at the start line in more detail. The method, for example, get, post, put. This basically tells the server how we're going to send our data. Then we're going to send to the file path that basically dictates where we're sending the data. Then the version of HTTP. Then we have the headers again, configuration, where we're sending it, where it came from, the encoding, etc. This comes in the form of key value pairs. In this case, we have the key of host and the value of secaura.com. If we had to say cookie, the key would be cookie, and the value would be, say, our cookie of 1337 or subscribe or something like that. Then we have the body. The body, again, basically contains information for our request. If we're uploading a file, the file goes in the body. If we're sending complicated parameters, it goes in the body if it's a post request. If we're using a GET request, parameters can go in the start line. However, in most cases, it's going to go in the body if we are indeed using a post request or anything like that. I'm going to do a video on those particular bits and pieces in future, but this is just a high-level overview for the moment. To summarize, the start line has the method, for example, post, get, put. Get may say get some data, post will be we want to send some data, like a JSON object. Then we have the file path to, basically where we're sending our data to, for example, index.php. Then the HTTP version. In the headers, we then have config information, how we want to send the data, how we want to receive the data, the encoding or anything to do with our body and that kind of thing. Really just setting up the request for the web server to process. Then we have the body, again, just containing JSON, binary data, or anything we're sending across there, and parameters as well, if we're using, for example, a post request. Next, let's take a look at what a HTTP response looks like. Much like a request, 3 sections here. We have the start line, the headers, and the body, all very similar to a normal request, except with a few variations, and in plain text, but can be binary as well. Let's take a look at the start line. In this case, there's often 2 or 3 top lines. We have the version, what we saw in the request. We have the status code. This dictates basically how the server responded to our request. 200 for OK, for review for forbidden, etc, etc. I'll do a video on that in future. Then we have the response headers. These dictate things like setting a cookie, the current host, or anything like that. Really just configuration stuff on the response side. I'm going to do a full video on those particular kind of headers in future, so look out for that. But really it's a case of just, telling the client information about the server response. For example, the encoding and what to expect. Finally, we have our body in the response. This could be anything really that we've requested, an image, it could be binary, it could be the HTML file we've requested, CSS, JavaScript, etc. Anything like that will be returned in the body of the response. Things like PHP won't though, as they're server-side code, but client-side stuff, CSS, etc. will be, including images and files and binary stuff. They will be in the response body, however they will be encoded in a way that can be understood and will not be in ASCII, as ASCII won't be able to represent fully the binary data being sent. Let's take a look at an actual HTTP request response cycle in a web application. I'm going to go ahead and use BurpSuite to basically proxy the connection, so basically be able to intercept the request before they're sent, just so we can have a look at them, and which will help with the demonstration. Alright, cool. So let's go ahead and check out spider.htp. I'm going to go ahead and let this run through. Go ahead and drop that. Go ahead and go to the main page here. And we should now see that we're getting, we have an entry in here for a few things. We can see here, we go in, when we go to the root web app, so just slash here like that, you can see here that this is the request that we made. We made a request to get, so method, the root of the web server, HTTP, which is our version, the host headers, the user agent, which is basically saying, hey, we're Firefox, what kind of data will I accept in a response, the kind of encoding we'll accept in a response, and our session token or cookie. You don't have to worry so much about this one. Then in the response to that request, we then have the version of HTTP, the status code, so 200, the worded status code, so OK. We have the server, this based on what server it's running, so in that case Ubuntu Nginx, the date, the content type in the response, so in that case text HTML, and then it's telling us to set a cookie, and then the length of the content, so 11,273, which is basically all this here. Okay, so now we've had seen a very, very basic request and response. This being the request, this being the response. Let's take a look at how the cookie is set. Okay, we can actually see there's a set cookie header here, which is interesting. Let's go ahead and basically go over to Repeater. Repeater is basically a tool that we can use to just see the request response cycle. I'm going to go ahead and hit enter here, and actually we're going to get a cookie here. So let's go ahead and actually add that cookie just to shut the web app up for the moment. We've now given it a cookie. Let's try another cookie. I want the web app not to ask me for cookies anymore. I want to demonstrate how when we don't provide one, it asks us for one. Okay, let's have another go. Okay, never mind. Well, anyways, the point I'm trying to make is the web server will issue us the set cookie header, and the browser will then provide store that cookie inside it, and then we can then use it in subsequent requests. For some reason, this web app doesn't seem to like our cookies, but that's okay. All right, so let's go ahead and actually look at how this works. So if we go ahead and go into an incognito browser, go to private window, go to inspect element, and then go into storage. If we go to spider.htb, we'll see that right now we have a cookie associated. If we go ahead and delete this cookie, it should let me in a second. Delete all. If it wants to actually work, delete all session tokens. There we go. Cool. And go to the network and go to refresh. We'll see here when we go to it in our request, in our response. I don't want the preview. I want the actual response payload. Nope, I don't want that either. I want the I want the response headers. You can see here the session token. It's been set here, so it ends in ZA. And hopefully, assuming the wire doesn't mess with me, we should have ZA in our thingy. Indeed, we do. And then you can see that it's stored inside the storage with the web browser. And then whenever we make subsequent requests, for example, if I go ahead and open up the proxy, go to intercept, go ahead and make a request. I hope this is the right one. No, it isn't. The other one. Go ahead, say to /cart. You can see that our cookie is then in the request. Makes sense? Hopefully. That brings us on to our next thing. Here we're getting a resource /cart. I mentioned to you before, we have like say / here, and this is a resource locator. Basically, it's in where we're actually referring to. If we go ahead and go to repeater, we hit send here, we're going to get 302. That's because basically in order to access cart, we need an actual entry in our cart. So we're going to get a redirect, okay? That's okay for now. But if we go ahead and add something to our cart, which I'll demonstrate in a minute, you will see that it's actually going to give us a proper page. So let's take a break from that for a second. Let's have a look at an image and we'll come back later, okay? Let's go ahead and turn the intercept off. And I want to go ahead and look at an image, right? So we've looked at basically getting some raw HTML content. Let's try an image, okay? Let's go to here, internal server error. Let's go ahead, click here, go to copy image location, go to my burp, intercept, go to here, paste. Okay, that's now made a request there. Now, my burp didn't capture. It didn't catch that because I need to enable it in my burp settings, basically to capture it, unless I don't know why it didn't there. It should have done. Perhaps it's because it's cached. Let's go ahead and try a different image. Perhaps that's the reason. Let's go ahead and try, say, this image. Yes, get product details. I want to go ahead and basically get this image now. Copy image location. Okay, burp just doesn't want to intercept it. That's okay. What I'll go ahead and do is I'll go ahead and I cleared my cache. I went ahead and re-requested it, and now we can see here that we have a request made to the image. Okay, why did that work? Well, the reason that worked is because basically when we made a request to here, you can see here there are currently no headers. If we go ahead and hit send here, you can actually see in the response it's sending us a cache control header. Basically, what's happening is the server has said, hey, first of all, here's the contents of the image, and second of all, here's a thing to say, hey, this is when the image was last modified. You don't need to keep re-requesting this image, just store it in your cache for us. So that's what it will do, basically. If I go ahead and allow this through, and I go ahead and re-refresh, you should now see that there's now an if modified sense entry in my actual request. If you go ahead and into our repeater, you can now see in comparison, we have this, which is just, getting it and then some accept stuff. Then this one, we have some if modified sense. Basically what it means is the web server has then responded with these particular headers. The browser has then read those headers and then added them into our subsequent requests, adding basically this data into here, and therefore it's when I make the request to it, it's not going to work. We're going to get 3 or 4 not modified. Let's go ahead and remove this, because basically the server's going to read those. Go ahead and hit enter, and now we should get the raw contents back. Go ahead and take them away and hit send. We're going to get 3 or 4 not modified. Interesting. So basically we can modify this, for example. If it's been modified since this date, then, do something. Otherwise, we can just remove it and it will act as normal. Go ahead and hit enter, and then we have the image. Okay, let's go ahead and look at a post request. So we've covered get requests. Let's look at post requests, okay? So a post request basically is the same as a get request, except in this case we're adding a few additional bits and pieces. In a post request, we're including the body. We have the first line, we have the headers, and then we have the body. Post requests will basically use bodies in most cases. Let's go ahead and show you an example of that. So if I go and clear my proxy, go ahead and go off here, go over to where I was before, go to the index, pick, say, a nice lovely chair. Let's go ahead and pick this one. Go ahead to intercept, go to add to cart, and here you can see there's a post method. Basically, the post method says, hey, we're going to be posting some data. Get means we're going to get some data, or at least that's what it's supposed to be used for. Whereas post means we're going to send some data. In our case, we are sending the data of I want to add the chair to my cart. And you can see here we have post. We have the name of the item. It varies from application to application, but in this case, the way that we're sending the data is basically by posting to the ID of the product, along with the new item ID in our request. Okay. Additionally, we can see some of the bits and pieces. We have a content length. That's because this is 21 characters long. If we go ahead and add in this button here, it shows us all the new lines. So we have a new line here, and then this is 21 characters long. If I go ahead and add a new line here, you'll see that there's actually an additional 2 characters here. If I go ahead and remove that new line, you can now see it's just back to its normal 21. Okay, what else is there? So there's also content type, saying basically, how we want to encode our input, and so the server knows basically what kind of data we're going to send. And this is basically just some user input. I'm going to go ahead and forward that, and you'll see that basically the page just responds with you've added it to your cart. Let's go ahead and look at some other examples of post request. Here I have a PHP web app running a little bit of code. Simply a little post request that submits a comment, and then we have an image upload. I want to go ahead and look at both of them. Let's go ahead and leave a comment, say subscribe to Sakura, go ahead and add my intercept, go ahead and hit enter, and we can see here in the post body we have comment. We can go ahead and hit repeater, and we can go ahead and see that in here we have Sakura. Basically, this is a comment. Now, interestingly, I can go ahead and, because the way the web server is configured, in here, I'm using the request variable. I can actually use get as well in this case, so I can actually send data in the get request. So how do I send this parameter in a get request? Well, actually what you do is simply, if I change request method, you'll actually see that I'm actually appending this argument to my actual first line, and then we get that back. You can see here. If I actually go ahead and remove all this, like this, we'll probably still get the same data. Indeed we do. So I can just send the one line, and it actually will send all the data. Interesting, if I go ahead and say add a please in here, you can see here it's still reflected. See? And interesting enough, actually, it's included the next line of our thingy in here. That's because it's glitched. Go ahead and add that. There we go. We don't even need this. The web server's actually handled it without, but in most cases you will, so let's keep it in there and not confuse you. Let's go ahead and look at some more post requests anyway. So this is basically a post request, right? We're sending a parameter and a name value pair and the value. Okay, let's go ahead and look at, say, a file upload. Go ahead over to here, go ahead and upload a file. Let's say car.jpg. Let me go ahead and open up my interceptor in proxy. Go ahead and open, hit upload image, and now we can see a few different bits and pieces in here. Now we have basically we're posting to this resource on the host of 009,000. We're sending a multi-part form data in our content type, basically so the server knows what to do with the data and what kind of data we're sending. And this is basically the data we're sending. This is actually glitched, so I'm going to go ahead and rerun this just to make sure it shows properly this time. Go ahead and upload the car image again. Go ahead and open up the intercept. Yep. Go to upload image, and now it should be working. In this case, there's a few variations. Now we're sending the same data, except now we actually have the image data. You can see here the image signature, basically how the image is put together. You can see actually we have like a content type of image / JPEG. If I went ahead and modified this to a PHP file, we'd probably get like PHP as a content type. So the actual HTTP web server will actually process and say, it's a PHP file, it's a web file, it's an image file, etc. Here's the content length saying, hey, there's 75,000 bytes of data we're sending, and this is the data we are sending. And just really a case of just obviously telling the web server what we're going to send. Let's go ahead and go into repeater, go ahead and hit send. In this case, we're going to get a 404 because basically that upload.php doesn't exist in my case, but that's okay for the moment. This will just suffice as a basic example. All right, cool. So what have we learned from here? Well, we've learned there's a get request basically to send, to grab some data. There's post request so we can, post some kind of data. And we've also learned how, the cookies work and all that kind of thing. That should hopefully give you a rough idea as to how things work. But before we end here, I'm going to go ahead and look at how it looks in wireshark. We have a number of requests that have been made here. Let's go ahead and check them out. So if we go ahead and say grab, I don't know, this one might be interesting. Go over to follow, go to HP stream, and we can see here that we made a post request with our subscribe to Sakura contents. And then we can see here in the response, basically the response data, we have all the HTTP stuff, and then we have the actual HTML, and then our user input, which was obviously reflected on the page based on the PHP code that we had embedded. Let's go ahead and look at, say, another one. Go ahead and can I move there? I want to look at the next stream. Let's go ahead and check out, say, this next stream here. Go to follow, HP stream, see what else there is. Here we're getting a favicon. So the favicon is basically the little icon, you know, like this E here. It's a little icon. Here we're just getting the favicon. We're getting a 404, and then the web server's being, okay, that's fine, don't worry about it, kind of thing. Let's have another look at some other stuff. Say go to, say, upload.php, go to follow, HP stream, and here we have the upload where we uploaded an actual image. You can see here we have car.jpg, and again, just simply posting to upload.php. The headers, the kind of data we're sending. So for example, we're sending a multi-part form data. This is a boundary here that basically dictates where the data starts and ends. You can see here it ends in 1860. You can see here the 1860, and then right at the bottom of the request, we have that same border of 1860. This basically tells HTTP where the data ends. It's actually here, and then afterwards, it's basically just saying the name of the file, the describing basically what we're sending. We're saying just submitting the word submit. Okay, and then we have the response, which is just a 404, and then all the headers, and then the actual response body. This for example could be a file, could be JSON, binary, could be anything really, CSS, that kind of thing, whatever. It's really a case of obviously just messing with them and learning from that way. Cool, so that should hopefully give you an insight into HTTP requests and responses by looking at some actual real examples. Congratulations, you're now one step closer to being a web hacker. Join me in my next video and my series to learn more, develop, grow, and become the best web hacker. Oh, and like and subscribe, that'd be super helpful. Thanks, bye.